Hello and welcome to a short demonstration of what we call in project management the 7 basic quality tools. My name is Mariano Prea and I'm a PMP trainer. So the scope of our today's presentation will be this one, the 7 basic quality tools, and for that reason I will name what those tools are, which are commonly recognized in quality management all over the world. And as well, I would like you to understand, and I will share with you some common tips and tricks how to recognize this type of questions in the examination for the PMP, and how to best take the best answer of those. And let me start with maybe the most known one, which is cause and effect diagram. Cause and effect diagram. This has also other few names, and another name is Ishikawa, from the Japanese guy who discovered this. Another name is fishbone. And yet another name is root cause analysis. Root cause analysis. Why is called like that? Remember, fishbone, it has the shape of a bone of a fish. So you start with a defect. So this is an issue or a defect. Let's say, I don't know, many pieces which are larger than they are designed, and then you start understanding why that happened. So we have human reasons, we have technology, we have outside factors, some legislation, whatever, raw materials and so on. And as you can see, you can go and ask why this happens a few times until you act on some very deep causes, very important causes issuing this problem. So this is cause and effect. I missed to tell you guys that quality management is so important in project management. One of the big theoreticians, which was Philip Ross, said once, quality is for free, but only to those who are ready to pay heavily for it, which means it is not really for free. Let me go and talk a little bit about another important method in quality management, which is Pareto. And this is a guy who discovered in the years 20s, in the 20th century, that like 20% of people had like 80% of the money in the world, or in Italy, I don't remember exactly. Actually, this is even worse today. But this concept resisted, and it's called, you'll find in the examination also this name 80-20 rule, which means 20% of causes determine 80% of issues. Which means, in other words, that if you act on this 20% of issues, if you take an action, then you will resolve this one. That's why it's important to concentrate the efforts in project management. Imagine that you will ever have problems in your projects, and we all do as project managers. That's why we have to concentrate our efforts where we can get the most outcome of it. So that's Pareto. Kind of related to Pareto is histograms, which is a method to determine the relative frequency of the outcomes of some measurements. Okay, it can be something like that. We had in time, I don't know, 100 pieces of this kind, then 80, then 60, then 120, and so on. And Pareto actually is a particular form of a histogram. because it's like that. You find the most important causes and you act on these ones, and you will solve that many. So it's, let's take outside, in other words, these ones which are less important, because here we have to concentrate our effort. Alright, if we go further with another one which is check sheets. Check sheets. This is also, and you'll find this name in the questions. This is also called tally sheets. Tally sheets. And if you are bored with my red color, I will start using green, because I hope we'll have spring soon outside, even if it's just January. A particular form of a tally sheet is our checklists, and we all use checklists in our lives, which means imagine the quality guys going into any of your projects, and they have like a template saying, did John did this correctly? Did he measure every day like design? Yes or no? And they make some checks, some marks on everything, and they make a score. And if that score is above a threshold, then it's fine. If not, you will have to make some changes in your project. So again, an important tool helping the project stay healthy. What else? We can also speak about scatter diagrams. Scatter diagrams is putting in relation two measures. For instance, temperature inside the room. Is it dependent on the temperature outside? Most probably yes. Alright, and if it's like that, we will make some measures in time. Let's say this is time in hours, and this is temperature in Celsius. And in my examples, we will probably have these measurements spread like that, which means we can have a line, which means they are related. If we put, for instance, in relationship, temperature inside the room against how many children were born in March 20,000, they will not be related. In that case, we will have the points probably like that, which means they are not related. This is very much used in experiments. And we have two other tools, process flows, and we all use this. An example is the PMBOK diagram. Supplier, input, process, output, customer. And to give you even a more simple example, it's every process that we use. We have step 1, and then if this is true, we go like that. In step 2, if this is a decision point, okay? So this is a yes, this is a no, and if this is not true, and then we do something else, and something here, end of the process. So this is a process flow. Very much used to document whatever we do. Remember, we'll have to transition our projects to operations, so we have to have a good documentation ready. Right, and number 7 on our list will be our control sheets. Control sheets. And here we'll have to understand what are the limits of our process. You will just pretend you understood that for the moment, and I will make a drawing here. So this will be our number 7. And if this is the average, imagine you will have to construct a piece of material which is 10 millimeter wide. So this is 10 millimeter exactly, and our limits will be 10.02, 9.98. So this will be upper control limits and lower control limits. And what we will do, we'll make many measurements. Okay, so this is the axis of time here. And we will make some measurements. Let's imagine we have 10,000 pieces and we pick 100 randomly. And some of this will be like that. Okay? Any measurements which is outside our limits means our process is out of control. Very important for you to remember for the exam. So this means the process is out of control. And another element showing to you that our process is out of control is if you have 7 consecutive points on the same side of the mean. This is the mean or the average. 1, 2, 3, 4, 5, 6, 7. Okay. So if you have at least 7 consecutive points, 1, 2, 3, 4, 5, 6, 7. That is another indication your process is out of control. So this is the rule of 7. Okay, let's make a short summary. 7 basic quality tools. You will have many questions around this in the exam. Most of the questions will be around cause and effect and Pareto. That's why I started with it. And you'll have to be able to understand and foresee what the best answer is and what is very easy to eliminate. And with this, thank you very much. I wish you good luck for the examination.